What is parametric modeling? Why is it better to model from a cube, not a sphere? What is decimation? In this video, we'll be covering the basics of modeling. We'll go through basic modeling tools, Booleans, sculpting, retopology, procedural modeling and CAD, and techniques for optimizing. This is episode 2 of the 3D Basics series, and if you're new to 3D, I recommend watching the first video before watching this one. Alright, let's jump into it. To recap from last video, a mesh is made up of vertices, edges and faces, all connected together as geometry. Most 3D modelers start with a cube. It's not required, but it's a nice way of starting out with good topology. Starting with a sphere or cylinder often introduces n-gons or triangles right away, which we want to avoid. And even though 3D modeling can look complex, it really comes down to a handful of core actions. Cut slices geometry to add loops or cut the model up. Extrude pulls out geometry and creates thickness from vertices, edges, and faces. Inset is similar to extrude but pushes inwards instead of outwards, and that's perfect for details like a window frame. Bridge connects separate vertices, edges, or faces to fill gaps. Bevel or chamfer is used to round or flatten edges, and some apps can even let you customize the profile of the bevel to create more complex shapes. Merge and weld. This combines vertices and edges to clean up topology. In Blender, you can automate this by using merge by distance, which merges any overlapping vertices. Knife tool is used to make custom cuts onto your model. Another tool that can be handy is mirror, which, like the name suggests, mirrors the model on the other side, making the model symmetric. And sometimes you want to mix two shapes together. That's where Booleans comes in. There's union, which adds two shapes together, removing nothing. And then we have intersect, which looks where two shapes are intersecting and only keeps the intersecting part. Opposite of this is difference, which also looks at where two shapes are intersecting, but only keeps what's not intersecting. Booleans tend to create n-gons, so always keep an eye out on the topology when working with them. Booleans are also very common in CAD software where the geometry is parametric. This means that the geometry is built from math equations, not polygons. And with parametric geometry, Booleans can usually be used without topology issues. But what if you need organic shapes? Well, this is where sculpting comes in. Sculpting lets you push and pull geometry like it's clay. It's a very natural way of doing 3D modeling, and the best way to create anything organic like humans or creatures. If you have experience with digital art, sculpting can feel very similar. For example, like many 2D art programs, most sculpting softwares have brush libraries. There's a lot of brushes, but usually you stick to a few brushes most of the time. For example, the standard brush, which is an all-rounder. You'll use this one a lot. Then we have the clay build-up brush, or just clay, wax, or build brush, which many artists use to block out shapes quickly. It's also a nice way of sculpting muscles. Next is pinch, or knife, draw sharp crease or Damien standard, which makes a thin crease or cut into the sculpt. This one is super useful, for example when sculpting things like wrinkles, eyelids or nails. We also have flatten or scrape, which just like its name, scrapes off details and flattens the area. And then we have move or grab, which, well, grabs a piece of the mesh and drags and pulls it. And if you want to avoid sculpting on a specific area, you can use mask brush. There's also special brushes, for example brushes that work like stamp brushes in 2D, but in 3D. You can basically tap your sculpt to attach anything like ears, eyes, scars, or basically anything 3D onto your model. And some things are really hard to make with pure sculpting, like ropes, so there's brushes for that too, using curves. And all brushes usually differ from software to software, and there's many ways to reach your goal, so I recommend experimenting with the brushes in the app you're sculpting in. And also, if you want more concepts explained simply, more videos are coming up soon, so make sure to subscribe. Most people start their sculpt from a sphere, however it can be difficult and time consuming to turn a sphere into a full human body every time, so it's normal to start from a base shape to speed up this process. Some sculpting programs like ZBrush also have tools to quickly block out basic starting shapes. And if you keep pushing shapes, you can run out of polygons. And a solution to this is to use something like dynamic topology or Sculptress, which fixes this by continually adding geometry as you sculpt, so you never really hit a limit. However, high detail sculpts can get heavy and slow, and a tool like multi-resolution solves this by keeping multiple levels of detail on a single mesh. You can block out shapes on a low poly level, then switch to a high poly level only for fine details like skin pores, and then switch back to the low poly level to make some bigger changes, and it will apply those changes to the high poly model. This also helps your sculpt to run much smoother since the computer only needs to process the higher level details when necessary. However, one problem with sculpted models, the poly count is way too high to animate, rig or use in games, and the topology is often messy, and clean topology is important for performance, materials, rigging and animation. Turning a high poly mesh into an optimized mesh is called retopology. You can do this manually, which gives you the most control, or use automated methods. For example, voxel remeshing, which remeshes the model based on a 3D grid in space, and by changing a value, the 3D grid scales up or down, increasing or removing detail. Next is quad-based remeshing, which tries to generate a nice topology with only quads, and this works in many situations, but often creates ugly loops which can cause issues when working with the model later on. Then there's adaptive remeshing, which adds more or less details depending on where it's needed. So that means less polygons on flat areas and more polygons on detailed areas. Then there's decimation, which removes details gradually from the mesh based on a percentage. And this is a quick and dirty way to lower the poly count. Last one is very interesting, which is a hybrid or guided approach. This mixes auto remeshing with some user input. For example, you can often draw guides such as where you want the edge flow or important loops to go, and an algorithm builds topology that follows them. This is great for animation-ready meshes when you want to be fast with some control. So that's the basics of retopology, but there's other ways of creating models too. Like procedural modeling. Think of modeling or sculpting as a series of actions, like extrude here, inset that, delete here, and scale there. Usually the 3D software doesn't remember all these actions. However, with procedural modeling, that's a way of modeling where it remembers all these actions it took to reach the final model, and you can see the entire recipe and change it. There's a number of ways to do this, and they come in many names. For example, modifiers in Blender. And here's some examples of modifiers in Blender, and similar features can be found in other softwares as well. Array modifier, which duplicates a model multiple times in different ways. Ocean, which literally just creates an ocean. Smooth, that just smooths the model. Shrink wrap, shrink wraps the model on top of another model. Cloth turns your 3D model into soft cloth. And there's many more modifiers. In other 3D softwares, it's not always called modifiers, and they work in different ways. Cinema 4D has generators and deformers, often driven by fields, and in Autodesk Maya, we have deformers. And these modifiers and features are usually shown in a stack or list, which can get messy when using many modifiers. That's where nodes are very useful. You can think of a node as an action. First, it does this action, and then the next in line, and then the next. If we combine enough of these nodes, we can create some pretty complex geometry. In Blender, we have geometry nodes, and then there's Houdini, which is basically purely nodes, with different kinds of node systems depending on the task you're doing. It's very complex, but at the same time incredibly flexible and robust. In Maya, we have the dependency graph and Bifrost graph, and in Cinema 4D, we have scene nodes. Nodes are not only used for geometry, but also used in shading, rigging, and compositing as well. And one field where procedural modeling is very useful is in CAD software, often used in engineering and architecture. CAD creates procedural geometry with parametric constraints. This is essential when designing products or buildings, since dimensions must be exact, compared to Blender where creativity is often prioritized over perfect accuracy. And like sculpting, CAD models produces highly detailed models that are not optimized for performance. And to use this in games or animation, it would need to be retopologized. And we talked about retopology earlier. However, there are more ways you can optimize your models. When duplicating a 3D model, there's actually two ways to do it: creating a real duplicate or making an instance. Visually, they look the same, but under the hood, instances run much more efficiently. This is because the computer only needs to store one copy of the model in memory, and all the instances reference it. In practice, this means you can have thousands of instances while using memory for just one model. The Downside is that if you change one instance, all other instances change too. While with a real duplicate, each copy is stored separately, which uses more memory, but you also have the flexibility as you can make changes to each copy as you want. Particles, hair, and arrays all rely on instancing to stay optimized. Related to this, there's another modeling method I haven't mentioned yet. Modular modeling or kit bashing. Kit bashing involves modeling each component separately and then combining them to create a full model and save performance by instancing any components that are used multiple times. But even when using instancing, you can still encounter performance issues when using a lot of instances. And this is where LODs or level of detail comes in. Imagine if you want to add this car to your scene, and this looks great, especially close up, but when it's far away, it just looks like a yellow blob. You don't really need to see its details, so why even bother rendering it? With LODs, we can make multiple versions of a 3D model, one for each distance. The further away, the simpler the model. That's about what I managed to fit into this video, but fear not, I have 10 more videos in the works. In the meantime, if there's something specific you want covered in a future video, let me know in the comments below. And also, you guys really enjoyed the first video and many were wondering how it was made. So from now on, I'll upload every full project file in this series on my Patreon, link in description. And yes, it's basically fully made in Blender. Thank you so much for watching and see you next time.